Okay, so as promised, I'm going to provide you the full solutions to some of the examples from the notes video. So here's the first one. I recommended using substitution on this. I do still stand by that. So I would solve for y because it looks like the easiest to plug in here for. So y is equal to 24 over x. We're going to subs that in right here. So we get 2x squared minus 24 over x squared plus 4 is equal to 0. Simplify this here, so we get 2x squared minus, do that out real quick. Okay, I would clear my fractions next to get that variable off the bottom. So we end up with 2x to the fourth minus 576 plus 4x squared is equal to 0. Rewrite that real quick. Like that. I'm going to reduce everything by 2. So we get x to the fourth plus 2x squared minus 2, 8, 8. Okay. And then this should maybe factor. So let's see here, x squared and x squared. We're going to have 1 plus and 1 minus. And I just did some figuring in my calculator and got that this will be 18 and 16 equals 0. So I can solve both of those, and I get x squared equals negative 18. So x equals plus or minus, and that'll be 3 root, or excuse me, 3i. I still didn't put the I there. So 3i root 2, those are non-real answers, so it doesn't really help us. We can't plug those in and find the y value. And then we get x squared equals 16, so x equals plus or minus 4. So those are the ones we're going to plug in. And so we get 4 plus or minus 4y equals 24. You can really kind of plug these in at the same time because we're just dividing 24 by 4, both positive and negative. So if I plug in the positive, I get positive. If I plug in the negative, I get negative. And that's 6. So we get 4, 6, and negative 4, negative 6 as the two places where these will cross. And you can test that in a graphing calculator. These are whole numbers, so that should show up in your graphing calculator. Okay, that brings us to our second example. Again, I would be using substitution for this because you can get x by itself fairly quickly. X is equal to negative square root y. So I'm going to plug that in right here. So y squared minus 4 times negative square root y squared is equal to 12. Right? So y squared minus 4, when you square this, you're squaring essentially both of those. That's just y. And so you can really just write that as minus 4y is equal to 12. I'm going to get this equal to 0. And then factor. And I do factor these fairly quickly because you are expected to know how to factor what multiplies to negative 12 and adds to negative 4. So y equals 6 and y equals negative 2. I'm going to plug that in up here. So actually just right here. X equals negative square root 6. That doesn't simplify. And x equals negative square root negative 2. This is non-real. So it's not a solution to our system, but this one is. So this one has a solution at negative square root 6 and 6. Okay, so that leads us into this one. This one I would use elimination. I already started it on the notes, but starting it again, I would multiply through by 2. So this gives us 2x squared plus 4y squared is equal to 4. Line up your like terms, and so I should have leave a little gap here. So at the bottom we have 2x squared minus 3y is equal to 15. I'm going to subtract these, and so I'm going to switch all of my signs and then just add, really. So those go away, which is what I wanted. I have 4y squared plus 3y is equal to negative 9. So 4y squared plus 3y plus 9 equals 0. And I'm going to factor this, hopefully, out. So let's try 2y and 2y. Hold on. All right, that didn't factor quickly, so I'm just going to use quadratic formula here. And solve this out. And this is non-real. And so there's no solution. I'm going to go ahead and graph that in Desmos and make sure that there is actually no solution. Okay, so there's the graph of it. Again, the benefit of using Desmos is that you can just type it in just like it is. You don't have to manipulate anything. We can see that the ellipse is inside of the parabola. They never cross, never touch. And so that is, in fact, a no solution problem. Okay. So again, this one I already did most of in the notes, but just to kind of finish it off, I would multiply the bottom here by either 4 or 3. It doesn't matter. You can eliminate the x's or the y's. So I did 3 because they're already opposite signs. So I have 4 over x squared plus 6 over y to the 4th is equal to 7 over 2. And then down here I have 3 over x squared minus 6y to the 4th is equal to 0. I'm going to add those down. And so because these already have like denominators, you just add the numerators. These cancel out. And I get 7 over 2. So you can cross multiply. You would get something like this. But if you just notice that the tops are the same, that means the bottoms are the same. And either way, we end up with x squared equals 2. So x equals plus or minus the square root of 2. This is still a real number. So I need to go back up here and plug this in. So 1 over plus or minus the square root of 2. And let's just do, well, it doesn't matter. Let me show you why it doesn't matter. We're going to square that. Well, regardless of if we square a positive or a negative, we're going to end up with the same value. Sorry, I'm talking and writing at the same time. So we get 1 over 2 minus 2 over y to the 4th is equal to 0. I'm going to subtract this over, so negative 2 over y to the 4th equals negative 1/2. Cross multiply, get that y off the bottom, we get 4 is equal to y to the 4th. And so y is equal to the 4th root, and that's positive or negative 4th root of 4. 4 doesn't have a 4th root. And so we have the square root of 2 that goes with the 4th root of 4. And we have negative square root 2 that goes with the 4th root of 4. And then we have the square root of 2 that goes with negative 4th root of 4. And we have negative square root 2 that goes with negative 4th root 4. So this one has 4 solutions. And again, I just wanted to show you what this looks like on a graphing calculator. So I typed them into Desmos. You can see it crosses 1, 2, 3, 4 times, and those are the 4 answers we got. For some reason, this one's not letting me click on the intersection, but you could calculate those points of intersection. And so that graph's actually pretty cool, if I do say so. Okay, and again, this word problem, I all but did it all the way out, but let's just go ahead and solve it. It's real similar to the first one that we solved, but this says the diameter is 20. The diameter, if a rectangle is inscribed, which means it's surrounded through all 4 vertices by a circle, in a circle, then the diameter is the diagonal length of your rectangle, and that's true for any rectangle. If you're able to draw a rectangle in a circle, no matter what size circle, where all 4 vertices are on the circle, then the diagonal will also be the diameter. And so this is the diameter, it's 20. We know that this is the width and this is the length. This is a right triangle because it's a rectangle. So length squared plus width squared is equal to 20 squared, or length squared plus width squared is equal to 400. The area of a rectangle is length times width. So length times width is equal to 160. And this then creates our system. I know that length is equal to 160 divided by W, and I can then plug that in for length. So I have 160 divided by W squared plus W squared is equal to 400. Again, this is just like that first one that we solved. I'm going to go ahead and square this out. Okay, so I get 25,600 over W squared plus W squared equals 400. I'm going to multiply everything by W squared. So then I have 25600 plus W to the 4th is equal to 400 W squared. Move this over and write this in standard form. W to the 4th minus 400 W squared plus 25600 is equal to 0. This one is pretty big numbers to factor, but it's still probably going to be a little bit easier than typing these huge numbers into quadratic formula. When I do that, I just kind of mess around on the graphing calculator or on a calculator, any calculator, until I find 2 numbers that work. Okay, so I actually just used quadratic formula real quick and found that it was 80 and 320, but since it's not a quadratic, you have to make sure that you're square rooting those. So W squared is equal to 80. W equals plus or minus the square root of 80. We break that down into, let's see, we have 8, 10, and 16 goes into this 5 times. So W is equal to plus or minus 4 root 5. And then we do it over here. The biggest perfect square I found for that was 64. So then that breaks down into plus or minus 8 root 5. Since we're talking about a width, we're not dealing with the negatives at all, so we can just kind of disregard those. It's either going to be 4 root 5 or 5 root 5. So if we do 4 root 5 squared plus length squared is equal to 400, we can solve for your length. So 16 times 5 is 80, plus length squared is equal to 400. Length squared is equal to 320. And we already know the square root of 320 is 8 root 5. And so typically this will give you both dimensions, but I just wanted to emphasize that over here. So it is 4 root 5 by 8 root 5. Inches. Okay. And the next one, I'm not sure if you need to see it, but I will do it anyways. And I talked about equations in the notes, but you have just a regular line, so y equals 1/2 x. This one was where you have like a hill going up with a slope of half, and then this rocket is shooting off. We want to know how far up the hill it hits. All right, so it's not at a height of 0 because of the incline. So typically when it hits the ground, we're at a height of 0. Now because of the incline, we're not. It's landing up the hill. We want to know where that is. It gives you the other equation, y equals negative x squared plus 401x. We can just use straight substitution here. This can go here. So 1/2 x is equal to negative x squared plus 401x. I'm going to just subtract that from both sides. And we get 0 equals negative x squared plus 400. That's 0.5x. I'm going to actually multiply all of this by -2, just to make it a little bit easier on myself. So I get 2x squared. Now I have a positive lead coefficient, plus 801x. I'm going to factor out an x, and I get 2x squared plus All right, so if you do that, you get 0 equals negative x squared plus 400.5x. I'm going to factor out a negative x, and that gives me with x minus 405. So x is equal to 0. That's your starting height here. That doesn't help you. And then x is equal to 400.5. And this is how far it is to the nearest centimeter. All right, so about 400.5 centimeters. But then what point does the rocket strike the hillside? To find the point, you have to plug in the x value. And so we plug that into our original equation here. Or plug it in, and we'll just plug it into the other one. So 1/2 times 400.5 is 200.25. And so this point here, at which point it hits, is at 400.5, 200.25. Distance from the base, height above the ground. Okay. All right, and I think that was pretty much it for ones I needed to walk all the way through. But if you have any further questions, feel free to let me know.